Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Earlier lecture we are already discussed about the double integral over the general region, over the rectangular region, double integral over the polar coordinate system or Cartesian coordinate system. Today's session we are going to discuss about the change of variables in double integral by the Jacobian. Firstly, why we are using change of variable method? And in some cases, evolution of double integral becomes easier by the changing the variables. That means, suppose we have the function which is non-integrable, means sometimes we have the function which is directly cannot be integral. At that case, we have to apply change of variables. For that, variables x and y are replaced by the new variables which is u and v with the help of transformation method. That means x is a function of u and v and y is also function of u and v. For example, x equal to f1 of uv and y equal to f2 of uv. Then double integral f of xy dx dy equal to double integral f of f1 f2 into mod j du dv, where j indicated by the Jacobian, where Jacobian j equal to del of xy upon del of uv, means partial derivative of x with respect to u and v and partial derivative of y with respect to u and v, and expanding this determinant and substituting this value in our equation number 1, that is the relation between Cartesian coordinate systems and uv plane, means our image will be transformed in w plane. Using equation number 1, double integral can be transformed to the new variable, means substituting this value of j in this equation, and that is equation 1 becomes the relation between the Cartesian coordinate system and u and v, means xy plane to the w plane or a z plane to the w plane. Let's see one example based on the transformation method or change of variables. Evolute double integral 0 to 4 y by 2 to y by 2 plus 1 2x minus y by 2 dx dy by applying the transformation u equal to 2x minus y by 2 and v equal to y by 2. Here draw the both the region. Firstly, we have to starting with u equal to 2x minus y by 2 and v equal to y by 2, which is already given in our questions. Now here u and v both are function of x and y. Then firstly we have to find the j dash. If our x and y is a function of uv, then we have to find first j, but here our u and v which is in form of x and y, then firstly we have to finding the j dash. Then according to the properties of Jacobian, j dash into j equal to 1. Then after we get the values of j, means j equal to 1 upon j dash. Here firstly finding the j dash, then j dash equal to del of uv upon del of xy equal to indeterminant del u by del x, del u by del y, del v by del x, del v by del y, means partial derivative of u with respect to x, that is 1, partial derivative of u with respect to y, that is minus 1 half. Similarly, partial derivative of v with respect to x and y, that is 0 and 1 half. Now expand this determinant, that will give you 1 half, that is the values of j dash. But in this particular example we require the values of j. Then according to the properties of Jacobian, j into j dash equal to 1. Now substituting the j dash, then j equal to 1 upon j dash, then for this simplification denominator comes in numerator, then j equal to 2, that is the exactly answer of the Jacobian. But here we have the formula for the transformation, means dx dy, which is mod j into du dv. Then substituting these values of mod j, suppose we have the here minus 2 answer, then minus sign will be eliminated because here we have the formula of the modulus of j, then we consider only positive sign. Then substituting the j, that is 2 into du dv, that is our transformation form, means whatever the our image which is lies in xy plane, that is convert in W plane or a UV plane, then which is multiplied with mod j, that is our values of 2. Means that is dx dy equal to 2 du dv. Now firstly we draw the region, then according to the our question where x which is varies from y by 2 to y by 2 plus 1, then for the simplification of that term, that will give you 2 comes this side, then 2x equal to y, then 2x minus y equal to 0. For the second equation 2x equal to y plus 1 means 2x minus y equal to 2. Then here we have the formula or values of u equal to which is given in the question 2x minus y by 2, then 2x minus y equal to 2u means that is a 2u equal to 0, then u equal to 0, then substituting this here 2u, that is 2u equal to 2, here 2 which is cancel out, then u equal to 1, means we can say that u which is varies from 0 to 1. Similarly for the finding the limit of v, then here y which is varies from 0 to 4 which is given in the questions, then here 2v equal to 0 because values of y equal to 2v, then v equal to y by 2 which is given in the questions, then y equal to 2v, then 2v equal to 0, then we get v equal to 0. Similarly y equal to 2v, then 2v equal to 4, 2 2s are, then v equal to 2, means v which is varies from 0 to 2, that is exactly we have to find the limit u and v. Now draw the regions for that, means here our equations of line, that is y equal to 2x, that is line which is passes through the origin, and this is our infinite strip line. Similarly second equation which is 2x minus y equal to 2, that is our equations this line, then y equal to 0 which is lies on x axis, y equal to 4 this one, and these are the reasons we have to find the integral in Cartesian coordinate system or in xy plane, or which is also called the z plane. Now convert this image in w plane. For that we have to finding the limit and we finding the values of u and v, where u which is varies from 0 to 1 and v which is varies from 0 to 2. Then here this one is the u axis and this one is the v axis. Then you similarly we draw the in Cartesian coordinate system same as here, u equal to 0, u equal to 1, v equal to 0, v equal to 2. These all are the equations of the straight line. Then u equal to 0 which is exactly in v axis, v equal to 0 which is exactly on u axis, then u equal to 1 and v equal to 2. Then our shapes, parallelogram shapes will be converted in form of rectangular form. Now substituting this limit u and v in our double integral equations, hence the new form of the integral is I equal to 0 to 4 integral y by 2 to y by 2 plus 1 2x minus y by 2 dx dy. Now converting this limit in form of u and v, then our limit which is v vary from 0 to 2 and u which is varies from 0 to 1, here our x and y which is converting to the u and v, then 2x minus y by 2, that is values of u, and dx dy equal to mod j du dv. Here values of mod j, that is 2, then 2 du dy, means replace dx dy with the 2 du dv, that will give you 2u du dv. Firstly integral with respect to u, that will give you u square by 2, 2 which is cancel out, then upper limit minus lower limit means 1 minus 0, then integral with respect to v, that is 0 to 2 dv with which is v, where v which is varies from 0 to 2, then upper limit minus lower limit, that is 2 minus 0, that will give you 2, that is exactly we have to find. Similarly one more example, double integral r x square plus y square dA by changing the variables, where capital R is the region lying in the first quadrant and bounded by the hyperbolas x square minus y square equal to 1, x square minus y square equal to 9, xy equal to 2 and xy equal to 4. Firstly we have two equations of the hyperbola and we don't give the values of u and v, then first we have to consider the u equal to x square minus y square and v equal to xy. Means our u and v is a function of x and y. Then firstly we have to finding the j dash. Then j dash equal to del of uv upon del of xy, means partial derivative of u with respect to x and y and partial derivative of v with respect to x and y. The indeterminant del u by del x, del u by del y, del v by del x, del v by. Substituting the partial derivative of u and v with respect to x and y, that will give you indeterminant 2x minus 2y in second row y and x. Now expanding this determinant, that will give you 2x square plus 2y square. Here 2 which is common out, that will give you 2 into x square plus y square. According to the properties of Jacobian, j into j dash equal to 1, then j equal to 1 upon j dash equal to 1 upon 2 x square plus y square. Means our dx dy equal to mod j du dv. Then substituting these values of mod j, that will give you 1 upon 2 x square plus y square du dv. Now first we draw the regions and finding the limits of u and v. Then here we have the equations of x square minus y square equal to 1, xy equal to 2, xy equal to 4 and x square minus y square equal to 9. These all are the equations of the
hyperbolas.
Here we have the equations x square minus y square equal to constant, that is the shape of hyperbola which is like this, and xy equal to constant, that is also shape of hyperbola in opposite quadrants, means like this opposite quadrant which is drawn here. But here we consider the in first quadrant, that x square minus y square equal to 1, x square minus y square equal to 9, xy equal to 2 and xy equal to 4. Then this type of region we consider, this is our capital R. Then transform this region in UV plane, that is our region capital R dash. In this indicated by the Z plane and this region indicated by the W plane. Now we have to finding the region in W plane or limit of the u and v with the help of the region of the xy plane which is bounded by the curve x square minus y square equal to 1, x square minus y square equal to 9, xy equal to 2, xy equal to 4, and transformed into the square in the uv plane. Means x square minus y square equal to u, then u which is varies from, that is the values of u, then u equal to 1, that is the values of u, then u equal to 9. Means u which is varies from 1 to 9. Similarly xy equal to v, then v equal to 2 and v equal to 4. Then v which is varies from 2 to 4, which is drawn here, where u equal to 1, v equal to 1, v equal to 2, u equal to 9. These all are the equations of the straight line. Means our limit which is varies from u which is varies from 1 to 9 and v which is varies from 2 to 4. Substituting this limit in our integral, hence the new form of the integral is I equal to double integral over the region x plus y square dx dy double integral r x plus y square 1 upon 2x square plus y square du dv. Here x square plus y square which is cancel out, and where 1 by 2 which is constant comes out, where v which is running from 2 to 4, u which is running from 1 to 9, dvu dv. Here both has a constant limit. Then with the help of variable separable form, then integral with respect to u and with respect to v both the together, then v where v which is running from 2 to 4 and u where u which is running from 1 to 9, then upper limit minus lower limit, that will give you 4 minus 2 into 9 minus 1 into 1 half, and for the simplification of 8, that will give you exactly 8. That is our required answer. Let's see one more example. Evaluate the double integral 0 to 1 minus x y upon e raised to x plus y dy dx by changing the variables using transformation x plus y equal to u and y equal to uv. In our example, we have the already u is a function of x and y and v is also function of x and y. But here one equation making the subject as a u in form of another equation making the subject as a y. Then we convert this form in making the subject as a u and v or making the subject as a x and y. Then for that, substituting the values of y equal to u minus x in this equation, that will give u minus x equal to uv, then x equal to u minus uv, then here u which is common out, then 1 minus v, means here x is a function of u and v and y is also function of u and v. Then we have the two equations, y equal to uv. Then here we find the j. In above example, we have to finding the firstly j dash, then after j. Then here firstly we have to finding the j, no need to find the j dash, that is our Jacobian, whatever the answer, and this answer will be substituting in dx dy equal to mod j du dv. This answer will be substituted in directly, that is our transformation form, means Cartesian coordinate to the w plane or in other variables which is uv. Here we have to finding the limits of u and v, where y which is varies from 0 to 1 minus x and x which is varies from 0 to 1, means firstly draw the region, here x axis and y axis, then x equal to 0 which is lies on y axis, y equal to 0 which is lies on x axis, here 1 minus x, that is x equal to x plus y equal to 1, that is equations for the straight line. Then intersection point which is 1 0, this one is 0 1 and this one is 0 0. Now at this particular region we have this is the xy plane and this image which will be converting to the w plane. For that we have the equations, means x plus y equal to 1, then u equal to 1, which have to give directly. Now we have the equations which is solved above, then x equal to u 1 minus v. Now substituting the x equal to 0, then u 1 minus v, then u equal to 0 and v equal to 1, means we already find the limit, means u equal to 0 and u equal to 1, means u which is varies from 0 to 1 and we already find the v equal to 1. Now already question have a given y equal to uv, that means substituting the y as a 0, then uv, then u equal to 0 or v equal to 0, means v which is varies from 0 to 1, that is our exactly limit 0 less than or equal to v less than or equal to 1, means u which is v which is varies from 0 to 1 and u which is varies from 0 to 1. That draw the region in u plane, this one is a v, this one is a u equal to 0, this one is the v equal to 0, this one is the v u equal to 1 and this one is the u equal to v equal to 1, that is our exactly rectangular shape where v which is varies from 0 to 1, u which is also varies from 0 to 1. Substituting this limit in double integral and give the simplification, and that is our exactly answer. This is all about the topics of the change of variables. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.